Hello and good morning to everyone. So our today's lead code question is 1674, which is minimum moves to make array complementary. So basically in this question we are given an integer array nums whose length is n, and we are also given an integer limit, right? And in one move we can replace any integer from nums with another integer between 1 and limit, and limit is included, right? And it is given that array nums is complementary if for all indexes I, this sum nums of I plus nums of n minus I minus 1 equals the same number. That means suppose we are given this array 1 2 3 4. If we take, see, 1 plus 4, 1 plus 4, the sum is 5. 2 plus 3, 2 plus 3, again the sum is 5. So for every pair where nums of I plus nums of n minus I minus 1, the sum of these should be equal for all the pairs, then the array will be said as complementary, right? So what we have to do is we have to return the minimum number of moves that we require to make our nums as complementary, right? So let's move to examples. So let's see the first example. In the first example we are given the array 1 2 4 3 and our limit is 4. That means we can replace any number from 1 to 4, 1 to 4. So see, 3 plus 1 4, and 4 plus 2, the sum is 6, the sum is 6. So suppose if we replace this number 1 with 3, 1 with 3, then 3 plus 3, our sum will be 6, and this sum is also 6. So to how many moves that we have used to make our array complementary? So we just have replaced one number, so the number of moves is 1, so that is our answer. So let's move to the example number 2. So in example number 2 we are given this array 1 2 1 2. So some of these first and last pair is 3, and second this is 3. So the array is already complementary, so no need to make any changes or any moves. So the number of moves that we have done is 0. So let's move to the constraint part. So n, which is our nums dot length, so n can be up to 10 ki power 5. So either big of n solution or n log n solution, right? N square will give us time limit exceed, right? And each element in the nums array, and limit can also be up to 10 ki power 5, right? Limit can also be up to 10 ki power 5, and it is also given that n, which is the length, is even. So let's move to the approach part. So basically what we have to do is, for every pair that is nums of I plus nums of n minus I minus 1, this should be equal to a target value. This should be equal to a target value. Now as we know we can replace a number from 1 to limit, right? 1 to limit. So target value range can be from 2 to 2 into limit. Suppose we have a pair a comma b. So if we replace both a and b with 1 1 with 1 1, then we get the sum as 2. So that's the minimum sum, right? Or if we replace both a and b with limit, then the sum will be 2 into limit. So that's the range of the sum, or we can say that's the range for the target, right? So our target range is from 2 to 2 into limit, 2 into limit, right? So if we have to find, so if we take every value as target from this range, and then we check the number of moves or changes that we have to done, and then take the one with the minimum changes, take the answer with minimum changes. So but the time complexity here is, so how many values we have for target? So for target we have 2 into limit values, 2 into limit values. And for checking, and for finding the number of changes, we take big of n time. So the total time complexity here is 2 into limit into n, and as we know n is lesser than equal to 10 k power 5, even limit is lesser than equal to 10 k power 5. So in worst case it will be 10 k power 10, which is too much and which will give us time limit exceed. So we can't follow this method, we can't follow this method. So basically we need a more efficient way, we need a more efficient way to calculate how many moves we require, how many moves we require for each target sum, right? Earlier what we were doing is we were taking a target, and then we were finding moves for that target, right? And but that will take n into limit time, so we have to somehow optimize it, right? So let's see how we can optimize it. So first, suppose we have a pair a comma b, where a is nums of I and b is nums of n minus I minus 1, right? And let's assume a is lesser than or equal to b, then the sum is a plus b. Now there are three possibilities for any target, there are three possibilities for any target. So first possibility is that we need zero moves to reach that target. So if we have 5 comma 2, then what is the target that we can achieve in zero move? So basically 7 is the target that we can achieve in zero moves, because that is the direct sum. Without changing any number, we are getting 7. So 7 is the target, 7 is the target, basically a plus b, that is the sum of the two numbers. So 7 does not require any change, right? So we can easily reach the target 7, right? So a plus b needs 0 moves. So this is case 1. So let's see the case 2. Case 2 is we require one move to reach the target. So in one move we can either change a, or we can either change b, right? Either a or b, right? And we can change a or b to any value from 1 to limit, right? We can change from any value 1 to limit. So if we change only one element, and then the achievable targets are, so suppose we change a first, then the range for a will be minimum a can be 1, then b will be same, and maximum value for a can be limit. So these are the range of the sum that we get when we change a. And when we change b, then we get 1 plus a, because minimum value for b can be 1 and maximum value for b can be limit plus a, right? So these are the range of the sums that we get when we change a and b. Now if we combine both the ranges, then from here see 1 and 1 is common. Now we have to minimize the left part. So what we have to do, we have to take the minimum of these two, we have to take minimum of a and b. So we take minimum of a comma b for the left range. In the right range we have limit as common, and now for the right range we have to maximize this range, we have to maximize the right range. So we take maximum of a comma b, so this is the range of the sum, that for that we require only one move, that is we need to change either a or b, right? Now so all the targets which are present in this range requires only one move. Now the case third. So we have seen zero move case, we have seen one move case. Now all the sums that are left, means all the remaining target sums, will always require two move, right? So we have to change both the elements to achieve the rest of the target sums, right? So that is case 3. Now what we do is, for every pair we assume that all the target sum initially require two moves, right? So for every target sum in the range 2 to 2 into limit, we assume they all require two moves initially for a pair. Then what we do is, then we find the range for one move then we find the range for one move. So all the elements or all the target sum that are present in this range, they'll require only one move. So we subtract minus 1, we subtract minus 1 from them, because initially we have assumed that they all require two moves, so we subtract 1 from them, right? And then the third case, the exact sum, that also do not require any move, so that requires 0 moves, so again we subtract minus 1 for that also, right? And what we and to handle these range updations, what we do is we use a difference array. And then once we have calculated the whole difference array, then we use prefix sum to find the to find the number of moves for each target sum, right? So to update the ranges efficiently, we have used difference array. So we maintain a difference array named as diff, right? And when we apply prefix sum on this, it will give the total moves that we need for every target sum, right? So let's see. So initially all target needs two moves, and our target range is from 2 into 2 to 2 into limit, right? So what we do is we will add we will plus 2 here, and then we subtract minus 2 in the next element, that is 2 into limit plus 1, right? So when we prefix sum, this two will be added to all the numbers in this range, right? To all the numbers in this range. Then we handle the one move range, that is those target sums that require one move. So the range is left is minimum of a comma b plus 1, and the right is maximum of a comma b plus limit. So now for the left range we have assumed that these require two moves, but these sums require only one move. So we reduce the cost by 1. So we put minus 1 at left range, we put minus 1 at left range, and at right plus 1 range we again add 1, right? So when we do prefix sum, all the elements in the range L to R, they will be reduced by minus 1, right? Then the third case, the exact sum case, that is the sum is equal to a plus b. So this point for this point a plus b, we have to reduce the diff by again minus 1, right? And then s plus 1, the next element will be added to plus 1, right? So for this point, that is a plus b, we again reduce the cost by 1. And then what we do is then we take the prefix sum over our difference array, and then this will give us the total moves required for every target sum. So what we do is that we'll take the minimum move as our answer. So let's try to understand with the help of an example. We have taken the array 2, 1, 4 and 5. So this is our array, and our limit is 6, right? So first pair is 2 comma 5. So we have taken the first pair 2 comma 5 and limit is 6. So first we see the case 0 moves. So if 0 moves means target is the sum, that is 2 comma 5. The sum of 2 comma 5 is 7. So 7 do not need to change any element. So for target sum 7, we do not need to change any element. So target is equal to 7, requires 0 moves. Then for one move case, our range will be 1 plus minimum of a comma b and limit plus maximum of a comma b. So 1 plus minimum of 2 comma 5 is 2, and limit is 6 plus maximum of 2 comma 5 is 5. So the range from 3 to 11, so these target sum require only one move, right? And the rest of the targets in the range 2 into limit, that is 2 into 2, 12, requires 2 moves. So let's see how we'll handle these ranges using a difference array. So initially we assume all the target sums from 2 to 12 2 to 12 will require two changes. So what we have done is we have put plus 2 here and minus 2 at 13, because all the sums from 2 to 12 require two moves, right? And then what we have done is then one move range. The one move range was from 3 to 11. From 3 to 11, so we do minus 1 here, and so from 3 to 11, so 11 is up to here, so minus 1 will be up to here. Then we again have to plus 1 here, because the minus 1 will be up to 11 only, right? Up to 11 only minus 1 should be affected. And then the third one is zero move. So the zero move element is 2 plus 5, that is 7. So at 7 we have to again reduce the cost by minus 1, and for only 7 we have to reduce the cost, so we again have to put plus 1 at 8, right? We have to put plus 1 at 8. So see, this is our array. This is our array after processing the first pair. Now our next pair is 1 comma 4. 1 comma 4. So again all the sum needs two moves, so we again put plus 2 at 2, so it will become plus 4, and we again put minus 2 at 2 into limit plus 1, so it will become minus 1. Then our one move range is 1 plus minimum of 1 comma 4. Minimum of 1 comma 4 is 1, and then limit plus maximum is 4. So our limit is 2 to 10. 2 to 10. So what we do is we minus 1 at 2. We minus 1 at 2. We have put minus 1. We have put minus 1 at 2, and we again put 11. We put plus 1 at 11. Plus 1 at 11, because our range is minus 1 will be from 2 to 10 only. So we again have to put plus 1 to the next of the elements, right? Then so it will become, see here, 4 minus 1 will become 3 minus 1. So this will be after processing one move. Now zero move case, that is 1 plus 4. 1 plus 4 is 5. So at 5 we have to put minus 1. So 2 3 4 5. At 5 we have to put minus 1, and again plus 1 at 6, right? Again plus 1 at 6. So our array difference array will look like this after processing both the pairs. So now the next thing is we apply prefix sum on this difference array. So we get 3 here, then 3 minus 1 2 here, then again here 2, then 2 minus 1 1 here, then 1 plus 1 2 here, 2 minus 1 1 here, 1 plus 1 2 here, then again 2, again 2, 2 plus 1 3 here, 3 plus 1 4 here. So this way we get our moves for each target. So for target 2 we require 3 moves. For target 3 4 5 6 7 8 9 10 11 12. So for each target we get the number of moves that we need. So the minimum number of moves is 1, which is for 5 and 7. So for 5 and 7 we get the minimum number of moves, which is 1. So our answer is 1, right? So let's see. Initially our array was 2 1 4 5, and we are getting minimum move for 1 at target is equal to 5. At target is equal to 5 and 7. So we see for 5, so we get the first pair 2 comma 5. So if we change 5 to 3, that means one move, we get our target sum as 3 as 5, sorry, 2 plus 3 is 5. Then 1 plus 4, same, target is 5, so no change. So we see only one move, and that is what we get after taking the prefix sum over the difference array. So let's move to the code part. So in the code part we have taken the size of the array, and then we have taken a difference array whose size is, so difference array is from 2 to 2 into limit. So size is 2 into limit plus 2 we have taken, right? And then we have iterated over all the pairs. So we have taken from I to 0 to n by 2, because 0, then the last element will be occupied with itself only. Then we have taken both the numbers a and b, and then we have find the range. We have find the range for one move, that is 1 plus minimum of a comma b and limit plus maximum of a comma b, and then we have find the sum. And now initially we assume that all sum needs 2 moves, so our range will be from 2 into 2, 2 to 2 into limit. So this range will need plus 2. Then we added 2 here, and then we subtracted 2 from here, so that the rest of the elements won't be added 2, right? Then one move range. So for one move range we have find the range is from low to high, so we subtract -1 at low, and then added again 1 at high plus 1, right? And then the third thing is exact zero move, that is for the sum, which is a plus b. So for sum we subtracted -1, and then we again added +1 at sum plus 1, right? So here, up to here, our difference array will be formed. Now after forming the difference array, we have to find the minimum moves. Right? So what we do is we find the prefix sum. We take the prefix sum from 2 to 2 into limit, 2 to 2 into limit, and then moves is equal to, we add the previous value, moves plus equal to difference of target, and then we take the minimum answer. We take the minimum of the moves, and then store that in the answer, and then we return the answer. So I hope I am able to explain you the solution properly. So if you like the video, please make sure to like, share and subscribe the channel. Thank you.